Right, so hello, welcome to this video tutorial for RC Hibbeler's Engineering Mechanics Statics textbook. So we have this problem from chapter 4 here, which is asking us to determine the resultant moment produced by the forces about point O. So I've replicated the diagram on the right here just so that we can draw all over it. A good place to start with this problem might be to decompose F1 and F2 here into their constituent horizontal and vertical components. So let's just quickly go ahead and do that. So for F1, we have this 500 Newton force acting upwards and to the right here with this 3, 4, 5 triangle idea here. I've replicated that down here. I'm going to trust that you guys are familiar with this idea that I've shown on the right-hand side here. We can basically say, almost by inspection, that the horizontal component here is going to take a value of 400 newtons since it's 4/5 of 500, and the vertical component here is going to take a value of 300. For our F2 here, we have a 600 Newton force acting down and to the right. It's 60 degrees to the horizontal. I'm going to trust again that you guys are familiar with this idea I've shown on the right as well. We can say that its horizontal component is equal to 600 cos 60, and that its vertical component is going to be equal to 600 sine 60. So we've kind of got decomposed representations of our F1 and F2 forces shown on the left here. That should hopefully give us a basis then to start taking moments. So we can say that the sum of moments about point O acting, let's say, clockwise is equal to, now let's start by considering clockwise moments. So the horizontal component of this of F2 here is going to enact a clockwise moment. So let's say this is going to be equal to this distance here multiplied by the horizontal component there. So we can say that's going to be 0.25 times 600 cos 60. What other clockwise moments do we have acting here? Well, the vertical component of F2 is enacting a clockwise moment as well. The perpendicular distance there is going to be 0.125 plus 0.3. So we can say, let's just say plus 0.425 times 600 sine 60. Is the clockwise moment enacted by the vertical component of F2 there. Let's have a look at F1. So the horizontal component of F1 is also going to enact a clockwise moment. So that moment there would be plus 0.25 times 500, or times 400, sorry. And then we would have an anti-clockwise moment from the vertical component of F1 here. And we can take the perpendicular distance again to be 0.425. So we can say minus, since it's an anti-clockwise moment, 0.425 times this vertical component here, which is 300. And now this is just a case of bunging all of this stuff into our calculator, right? We can simplify this down. So let me just show you a simplified version of this. By simplified, I just mean a factorized version, which involves less typing into our calculator here. But we could type either this or this into our calculator here. And when we do that, we should get a value here of 268 newtons, which I would leave as our solution here. Okay, so if you have any questions or comments about that problem, please feel free to leave them down in the comment section down below. Otherwise, thank you very much for watching.